remember, if a mathematician is investigating a sequence, they're probably interested in two things. The first is perhaps finding a closed form expression for the sequence, and the second is determining if a sequence is convergent. Mathematicians have developed some tools for determining if a sequence is convergent. It's important to know about these tools. The first tool is going to be L'Hopital's rule, which is a fundamental tool used in Calculus 1. The second is going to be something called the monotone convergence theorem, which we won't spend as much time on, but which is still important to know. So let's look at L'Hopital's rule. L'Hopital's rule says if you're investigating something that has a form like infinity over infinity or 0 over 0, what are called indeterminate forms, because it's possible for there to be more than one way that this can occur, and you're looking at a function or a sequence where you have a ratio of two functions, so you're looking at the limit as n approaches infinity of f of n over g of n, and you take their derivatives. So f prime of x and g prime of x are the derivatives here. That if you replace the functions with their derivatives, you get the same value. So if you hit a limit as n approaches infinity calculation, and you can't do that calculation straight away, replace the top and bottom both with their derivatives, and it will give you the same answer. As an example of this, let's look at the limit as n approaches infinity of 2n squared minus 7n all over 5n squared plus 3n plus 2. So I don't know what to do with this right away, because when I take infinity and I square it, I get infinity. When I take infinity and I square it, I get infinity. Both of these are tending towards infinity in the top and the bottom. So I can't do anything with that yet. However, this is an indeterminate form, which means I can apply L'Hopital's rule. So I'm going to replace this using L'Hopital's rule with the derivatives. So the derivative of the top is 4n minus 7, and the derivative of the bottom is 10n plus 3. Well, wait a minute. Did that help me? Not really, because this is still going to infinity, and this is still going to infinity. So there's nothing that says you can't apply L'Hopital's rule more than one time. You can apply it as many times as you need to. So let's apply it again. Now, if I take the derivative of the top, I just get 4. And if I take the derivative of the bottom, I just get 10. And so now this is 4 over 10, no matter what the value of n is. So the final answer is 4 over 10, or 2/5. So this does converge, this sequence does converge, and it converges to 2/5. Let's look at another example. So let's look at b sub n is equal to 3 to the n over plus 4. If I look just at this sequence and I look at the limit as n approaches infinity of 3 to the n over n plus 4, 3 to infinity is infinity, and infinity plus 4 is infinity. So this fits the form of infinity over infinity. Can't do anything with that directly. So let's apply L'Hopital's rule. The derivative of the top would be natural log of 3 times 3 to the n. The derivative of the bottom would just be 1. Now I'm comparing an exponential on the top to a constant on the bottom. So the limit as n approaches infinity is infinity over 1. Top is approaching infinity. The bottom is just staying 1. So the answer would be infinity. This sequence we have shown does not converge. Now again, you may see people write the limit as n approaches infinity of 3 to the n over n plus 4 is equal to infinity, and that's true, but infinity is not a number. So we would say 3 to the n over n plus 4 does not converge. It's not a convergent sequence. Let's do one more with L'Hopital's rule. So let's look at the limit as n approaches infinity, n to the 4th over n to the 7th. This definitely is infinity over infinity, so let's just bite the bullet and start doing L'Hopital's rule. The limit as n approaches infinity of 4n cubed over 7n to the 6th is equal to the limit as n approaches infinity of 12n squared over 42n to the 5th. Notice each of these is staying infinite on top and bottom. I square infinity, take infinity to the 5th power, I'm still getting infinity. So I apply L'Hopital's rule again, and I get limit as n approaches infinity of 24n over 210n to the 4th. I apply L'Hopital's rule again, and I get limit as n approaches infinity, 24 over 840n cubed. Be careful, because here you should stop. Each of these before was of the form infinity over infinity when you took this limit as n approaches infinity. But now when you go to this last one, it's not of the form infinity over infinity. It's of the form constant over it. So I have a constant here that is multiplied or divided by something going to infinity. So I have 24 gallons of Kool-Aid, and I give them to 840 times n cubed guests. And I keep inviting more and more guests. Eventually there's no Kool-Aid to go around. So this limit is equal to 0. Notice you could have also done this via algebra. And so in this case, it's possible to cancel. Could have done the limit as n approaches infinity, n to the 4th over n to the 7th is equal to limit as n approaches infinity of 1 over n cubed, which is equal to 0. Either way, you end up with the same answer. L'Hopital's rule in this case is a lot more work.